Right, thanks, Alan. So my name is Sharif Essa. So I work in TRIS or TÜV Rheinland industry, TÜV Rheinland, and I'm the APM lead. So I work for the digital team. I'm originally a mechanical engineer by background, and I was based in the integrity management function for most of my career. And within the last 3 years, I've moved into the APM realms. And you'll see how, as I describe it later on, how that's quite a good transition. But before we get started, I'd like to define what asset performance management means. There's a lot of acronyms that are used out there that are constantly interchanged to imply asset performance management, despite not being the same thing. So I thought I'd get us on the same line of thinking, and then I'd sort of take you through what we have to offer within TRIS. And so asset performance management is a holistic approach. So it's not just condition monitoring, it's not just preventative maintenance areas. You're looking at the entire asset in its wholity, and you're trying to analyze the data that's being generated from it from a maintenance perspective, along with a process perspective, in order to optimize all that data and improve your assets' reliability and operational efficiency. The approach enables operators to minimize unplanned downtime, reduce maintenance costs, and ultimately extend the lifespans of their assets, leading to an overall improved business performance. It's quite a complicated definition, but instead of looking at just one aspect of where the asset can go wrong, you're looking at the entire thing. And that's sort of the main takeaway I want you guys to take away from it. There's a lot of misconceptions out there that asset performance management is only for large enterprises, or it's just another name for preventative maintenance, and that there's some guarantees behind it. And when we go through the presentation, you'll see that there's no guarantees with asset performance management. It's just a toolkit to help you manage your assets. It doesn't guarantee anything. Why are people turning away to asset performance management or similar solutions that present with asset performance management? And we've categorized them as 5 key market drivers. And to be fair, within underneath all of these headings, there is a plethora of subheadings or variations of the same thing. But generally, people are trying to get the most out of their assets to meet current market demands and stay competitive. And within that, asset performance management has been championed as the sort of the way to get it, or the way to obtain it. And you can almost see why by my next slide, which is 30% of your OPEX is due to unplanned downtime, and anything that promises to reduce that is going to seem very attractive, which is what APM does, and it does really well. And the marketing behind it has been great. But as you can see, with all the benefits that comes with it, a lot of the APM projects actually tend to fail, with only a small number achieving expectations. I read somewhere that it was only 5% of projects that actually achieve the expectations that are set out. But I couldn't actually substantiate that number. But I imagine the number is probably close to 20%, maybe even 30%. And that's largely to do with sort of the basics almost. Business alignment, having an infrastructure in place, defining what success looks like. It's often one of the things that's overlooked is what is success going to look like, managing your expectations around these solutions, and a bit of a cultural deficit on site. So some organizations like the idea of what APM has to offer, but they haven't got the infrastructure in place to support it. And when I talk about infrastructure, I will highlight that to you in a moment about what I mean by it in the next couple of slides. The delivery of APM doesn't often include the people and process around it. It's just seen as the technology side. So you deploy the solution and that's it. So you don't factor the people or the process in. And without a shadow of a lie, and this statement I wholly believe in, is the software just is a tool. It's the people and process around it that release the actual value of the solution, and you're not going to get a single penny of savings without modifying or adopting the people and process element within your overall approach to asset performance management. And so on to the next slide. So what does asset performance management sit in? Now, this is the asset value chain, and we did steal this from, well, didn't steal it, it was provided to us kindly by ITIS, who are an APM solution provider. And this model has been developed over the last several years by a chap called Mark LaPlante from ITIS and Professor Tom Smith from the University of Wisconsin for ISO 5500. Sorry, 55,000. So it's a pyramid, and when you look at the bottom of it, you're sort of looking at your asset where you've just got a singular asset that you're trying to manage. You're carrying out the routines alongside it. Some of it could be measured in condition monitoring, others could be just purely preventative routines. But this is just looking at an entire asset. As you move up, you're managing a system of assets or a network. So it starts to become a little bit more complex. So instead of just one asset, you've got to start, you're looking at a set of assets, and you've got to start factoring the risks and how to prioritize your resources or the available pool of resources to help you manage the assets within these systems. And ultimately, the goal is to manage the performance versus cost versus risk. It's a difficult balance, but that's sort of what most engineers do these days as well. And this is just sort of around managing the assets. When you sort of move further up the chain, you've got the portfolio return on investment. So sort of the venture capitalists of the world, they're looking at how to make the assets as profitable as possible. So predominantly how to spend less and make more money. It's sort of relatively simple, and they're quite just interested in that one. And then when you go to the top level, and that's where the strategy gets derived, and that's sort of the crux of it all. And at the top level is the strategic level, where you're looking to keep stakeholders, both internal and external, happy by providing them with an understanding of what the assets are doing, how they're being managed, and sort of what value these assets are expected to generate over the next 5, 10, 20, 30 years, or whatever your operating cycle is going to be. And as you move up the value chain model, you're moving away from managing an asset over its life cycle to optimizing assets, optimizing value that these assets are driving, and what they were meant to achieve. So the next slide I've populated, or ITIS have populated, as to say, because they have provided us with this slide, is they've put a number of green boxes, and these are just examples within each of these sections. Some of the layers do overlap with each other, and different organizations will have different boxes in these sections to suit their requirements and their needs based on what they have or don't have. And as you can see, as you're moving up the chain, you're sort of moving away from transactional work, so just things executed in the silo, to things that are a bit more strategic. So you've got asset strategies, how you condition monitor all your assets, more than one, root cause analysis. And again, you're talking about the asset investment planning behind it. So where's your investment going to go, and how you're going to spend the money. On the far right-hand side, you'll see I've listed a number of applications, or ITIS have listed again. It is their slide. I should emphasize that. And these are software tools or applications that enable you to operate in these realms, but it's not by any means a comprehensive list. There's more solutions out there, but we've seen ITIS's solution, and we do quite like what they offer a lot. And it's a very thought out process, so we are championing them in this respect. And although how I've described the pyramid, it does come across as unidirectional, where you're taking the information from the bottom and feeding it towards the top. It is a bidirectional triangle. And as an example, if your organization is constantly in a reactive state, or just firefighting and preventing and just executing preventative maintenance, because that's all your budget allows, or that's all the KPIs you're measured on measure, then you're unlikely to move up. And it takes someone at the top, or sort of who's got the investment approach, to provide the finances or the resources, the appropriate resources, or the appropriate vision, or the appropriate KPIs. There's a lot of ways you can spin this to drive that message, where if they start looking at preventing assets from failure, rather than just how many failures have been, how many preventative maintenance routines have been carried out on a particular window of time, you need that investment in place, and without it, it won't interlink. So with a vision of where asset performance management sits, now we're going to look at how to approach it, or how to go from a failed project or a project that doesn't meet the expectations to sort of a more holistic approach, which in our world is the golden triangle. So we can, it's quite obvious in a lot of respects, where you combine people, process, and technology together. You're empowering the maintenance teams to suggest things, provide recommendations, and change either the process or recommend technology. And again, the people have to be involved with the technology before it can be implemented. So when it comes in, people know what they're expected to do. And again, that links to the process where you've got to streamline your workflows, see what people are doing, or you'd like them to do, so you're getting the appropriate KPIs out of place. And you've got to get the fundamentals right. If you haven't got the people, process, and technology working together, singing out the same hymn sheet, you'll stay in either planned or unplanned maintenance, and your costs will spiral out of control. Whereas when you start looking at condition-based maintenance, so you're looking at the condition of the asset alongside its performance, you start trending and edging closer to the middle of the path, or to the middle of the curve, where your number of failures reflect what your priorities are on site. I can't envisage that there'll be an elimination of failures altogether, but there'll be something to sort of minimize the numbers and put you in a more of a sweet spot.
Thanks, Sharif. Hello, everyone. I'm Paul Metcalf. I'm a senior technical consultant here at TÜV Rheinland, mechanical engineer of some years. I've worked for the business approximately a year now. Beforehand, I used to design engines for Cummins and worked in the steel industry for a couple of years. And before that, in the dim and distant past, I was actually an ICI apprentice, the very last one. So because of TÜV ABB's history as a former ICI division, I've sort of come full circle here. So I'm going to talk to you about the actual tie-ins of asset performance management with how to actually do a maintenance program. Thanks, Sharif. So before I discuss CMMS with you, that is computerized maintenance management systems, it's worth explaining that CMMS in itself and asset performance management are not the same thing. CMMS is maintenance management, that is the when, as in priority, and the how to do the maintenance. Asset performance management doesn't say when in the order of schemes, like which asset needs working first, and it doesn't say how to maintain the assets. It just says the asset needs maintenance. It's pinged a light bulb up saying something is not right, please help. So to CMS and the main point of this section of the discussion, which is RBM. So if we consider, as we should, that maintenance is value added, maintenance is always value added, no matter what anyone tells you, then RBM, which is risk-based maintenance, is a bit like hedging your bets. But like a gamble, sometimes a bit of insider knowledge can make the difference. So risk-based maintenance is about maintaining and bringing focus to the assets in your business which carry the greatest impact to the business should they fail. It takes away resource from those that don't have an impact or sufficiently low impact, such that the business can operate without them. Ostensibly, though it is suitable for most businesses, RBM is appropriate where limited resources are available to maintain the plant, be this people, materials, or funding. It's a methodology which concentrates on critical paths, establishing what or where these are and how they're going to affect the business. It is open to abuse, however. Some may use RBM to sacrifice asset longevity, fabric of maintenance, and worse still, safety protocols to provide funds to assets and systems which are financially lucrative. Shocking as that sounds, there is a historical precedent for it. Next slide, please, Sharif. Thank you. This is a general flow of RBM in respect of resources. You can see that once assets are divided between low risk, high risk, the resources, that is being funds, materials, staff, equipment, etc., the investment in the monitoring systems and the maintenance prioritization are all shifted towards the high risk assets. Low-risk assets are then left to a run-to-breakdown approach or similar, minimal spares retained and no specialised support. The analogy is you wouldn't spend £100,000 of maintenance budget on maintaining an office fan, your office desk fan. And conversely, on the other side of the scale, neither would you wait for the cooling feed pump on a blast furnace shell to break down. Unfortunately, sometimes that does happen. Not the desk fan so much, but certainly the latter. Next slide, please. So now introducing RBM within a CMMS system. Most maintenance software packages enable you to set up a risk-based maintenance system. CMMS is particularly good at setting up this type of maintenance, principally because it's database logic and it's reiterative monitoring of efficiency. So you put something in and you get something out and you reiterate, you go around in circles, and it becomes evolutionary. So CMMS is fundamentally made up of 3 building blocks. The first one, continuous improvement, taking what you already have, removing the bottlenecks, increasing efficiency. Number 2, building blocks such as the input data. What have you got to start with? Whether that be records, maintenance records, asset records, inspection records, manuals, maintenance manuals, the documentation which supports looking after the asset, standard operating procedures, SOPs, what are already recorded and how to actually approach this from the point of view of experience and learning. And the last one, reliability strategies, whether they be risk-based, reliability-centered, total preventative, run to breakdown, etc. Whatever your reliability strategy would be. In the case of what we're talking about now, we're concentrating on that risk-based one. It becomes more obvious now when you start to see this coming together that RBM, or any maintenance methodology for that matter, it forms an integral third of the CMMS system within any reliability strategy. So now we're going to look at the next 5 major steps that are needed when you set up an RBM system within the CMMS solution. Thanks, Sheree. So step 1, collecting data. As CMMS is a logic-based system, it makes sense to give it data to work with. Taking data from your DCS system, your digital control system that monitors the plant, historic records, maintenance logs, planned preventative maintenance, contracts, parts, work orders, schedules, financials, you name it. Start to create a picture of things, how they are now, and the challenges being faced, all put into numbers and statistics. So then the statistics, excursions, frequencies, allowances such as PSSR limits on an asset and the excursions that have occurred within that, trends, trend analysis, not just looking at limits in a binary way, looking at the grey area, the changes over time suggesting that an asset is wearing out, any ambiguity in the results, early detection that allows you changes in operation and maintenance practices to keep the kit going, build that picture. So by using data, we can come up with objective answers that have been derived in a largely free from human error way. You're looking at things statistically. That's what the computer works. The computer works ultimately ones and nothings, and you're trying to funnel it into that by reviewing the information you've got. Next slide, please, Sharif. So from there, we move on to step 2. I think you're a slide behind, Sharif. Another one, please. That's it. Thank you. Step 2, so evaluating risk. Reviewing each asset in the system. If anyone, by the way, owns an Audi, I have no sympathy for that picture. The man's made an unfortunate choice there and he's paying the price for it. So reviewing each asset of each system, using those existing records that we've already done in step 1. Perhaps you might be supported by an FMEA process or failure mode effect analysis process, or even a DFMEA process to start from scratch, to analyze that risk and provide us with a set of statistics. Then you ask yourself, what is the likelihood of a system or an asset breaking down? How often could this happen? Is there a backup system in place? Or perhaps you have multi-stream operation that mitigates the breakdown and reduces its impact. After all, single stream systems will always attract the highest risk. Dependent on the CMMS system or the software from that CMMS system that you're using, this process might be semi-manual, with the data input being in such a way that the risk ratings are actually an output of that data entry from the system. So it makes it quite a seamless process. Next slide, please. So we're on to the next aspect of evaluating the system, step 3. We look at the consequences of that failure. So we know whether a failure is going to happen or not. So building on step 2, if it does in fact happen, if it does fail, how is this going to impact the business? How long could the business be set back by? Is it going to be hours, days, weeks, months, or years? What is the cost of that system failure in lost revenue due to the breakdown? With this, we begin to target the bad actors. With a computerized system, it's actually possible that step 2 and step 3 are actually seamless, that are one and the same. It depends on the software that you're working with. Next slide, please. Now that we've got our risks and impact of that risk, we can start to rank that risk. So listing the assets and their ratings into a ranking system, you'll have 2 test models against this, likelihood and severity, and piecing those together, you start to get an output from it. And then we get to see which assets have the greatest cost. That isn't just financial, that is cost as in sort of impact and severity to the business for when it breaks down. The first indications of where investment needs to be made using a risk-based maintenance system. Next slide, please. With all that information together, we put it into the mixer and out comes the need to create a plan. We now know that what assets hurt the business the most when they fail, and it's going to be objective too, because it's based on numbers, consequences, costs, and time. It takes the political pain out of the situation. And with this, we can concentrate on those high risk to the business assets. What do we need to install to monitor those high risk assets? What technology can we use to support them? And this is where we get the tie-in with asset performance management. We can use continuous monitoring, particularly for changes which might cause immediate destruction or unreliability within the equipment. So measuring vibration using sensors and accelerometers, acoustic monitors, pressure sensors, thermal monitors, thermocouples, level sensors, flow meters, data control systems, displays, alarms, trips, limit switches, you name it, all the stuff that is giving you real-time data to assess what's going on with these assets and help protect you from the immediate failures. There's also periodic monitoring as well, the inspections. So where detection or deterioration is occurring over time, that's not going to cause an immediate destruction or a failure of the asset, but is ultimately leading to significant wear or changes that are going to increase the cost of upkeep on that asset. So visual inspections, non-destructive testing, oil analysis. These may all be used to create perhaps a digital twin. So again, we're tying in with the APM side of it. You might be doing a simulation of the real asset. But the main point of all this is to tie in with the APM and support the CMS system within its RBM regime and to help the process come full circle. We're looking at what's going on, how do we act upon it, how do we maintain it, and then from there we go back to the start, what's going on, what's changed, how are things improving. So as CMMS is all about maintenance scheduling, resources, labour, material planning, etc., it's in an ideal position to indiscriminately execute that RBM methodology with the activities and priorities based towards those critical assets that we've outlined in the previous slides. The tie-in between APM, CMMS, and RBM hopefully is a little bit more obvious now that we can see that big picture. And you can see, based on the 5 steps that we've done, that 2 to 3 points relating to RBM are evolutionary tasks, evaluationary tasks, which is the key aspect of continuous improvement, looking at how things are going, how to improve, what went wrong, what we can do better, and moving forward. The APM system is your feedback from that, because it's telling you what's going on within the asset, that CMMS can then schedule activities based on that data. So the principal logic in tying all this together within the CMMS system is that it frees up employee time, it increases accuracy, and it decreases the chances of human error creeping in. That's different from many other maintenance management systems, which focus on other aspects or focus purely on the asset in a black and white way. Next slide, please. So I said there was 5 steps, but the next one is, even though we've got step 6 here, even though your RBM has been introduced into the CMS systems working brilliantly, you may still need to justify its process and upkeep. I'm sure if there's any current or former maintenance engineers in the audience like myself, you'll probably appreciate where I'm coming from with these next few lines. For CMS system, it needs to output the costs spent on the asset and the improvement in reliability or availability gain as a result of these investments. So you've put a CMS system in place at significant cost. There's no two ways around this. It's nothing's for free. What happens next? Woe betide the engineer who has spent money on an asset in the form of CMMS or even maintenance activities as a result of it, and is unable to show an improvement in metrics, in maintenance metrics afterwards. And I'm speaking as the voice of experience here. Can you justify that activity? Have you actually made an improvement? Or if you can, how do you show it? So with this in mind, it's always worth remembering that to make an investment work, it needs 3 things: a need, funding, and willingness. So Sharif mentioned a triangle earlier, and the logic of this is the people process technology triangle. This logic is exactly the same. If you take any corner of that triangle out, it collapses. The project fails, or it fails to stick. So remember we mentioned about CMMS being a function of employee time, reducing the burden and the likelihood of uptake. Sorry, if you reduce the burden of CMMS, if you reduce the burden of maintenance and maintenance planning, the likelihood of uptake and the willingness, that is, to uptake it increases. Make things easy, people are likely to take it on board. If you make it difficult, then it's always going to fall by the wayside. It's that typical 5S function. So many companies get to the 3rd S, and then you've got standardize and sustain. It never happens. And you go back to the start. So you're constantly reintroducing those first 3 S's. This is exactly the same. If you haven't got that willingness and that need and the funding, it is not going to be adopted. I don't think is there another. Yes, there is. Sorry, I forgot to remind myself for a new slide. So where can TÜV help? TÜV Rheinland, or TRIS, as we sometimes call it, we get abbreviated to, has a group of very experienced consultants, in most cases, like myself, chartered engineers, who can provide or who have operational experience in plant maintenance across many disciplines, but also significant consultancy experience in delivering these CMMS systems to clients and the support and processes that go with them, such as RBM and RBI. We can provide guidance in the building blocks that underpin the RBM, i.e. getting you onto that initial step. What do you need? How do you get on the ladder? The team that Sharif and I work in have a broad and deep knowledge of plant problems. We've seen it across a wide range of industries. If you've faced it, at least one of us will probably have dealt with it. We have, I think the last time I worked this out, we have over 1,000 years of engineering knowledge in our team alone. And that's just in the present team. They're not everyone's 100 years old in our team. There's only 1 or 2 of them. And not only have we got that current knowledge, we've also got historic knowledge from our predecessors who are very, very good at retaining knowledge, passing it down through graduates, apprentices, and so on. So where you are facing issues with your assets, such as aging or deterioration, we can support with asset life management, asset life studies, asset life strategy reviews if you've got a strategy in place already, and the people, process, technology, health checks. We're there to help. And if you've introduced an RBM system and where you need to upskill your team in readiness for maintenance management, we offer training courses that help underpin the application of RBM, such as pressure systems training, piping design, machine legislation, and they are all orientated towards application rather than theory. You're building upon the experience that we have faced. And what we tend to do in the training courses is try and tease the information out of the delegates as well. So it's knowledge sharing. So if you're in a room with a dozen people, you're building knowledge based on that, not just on the lecturer. So I'll hand you back over to Sharif for now. And if you've got any questions on the subject I've just discussed on the RBM CMMS, we'll do that at the end of the webinar, and well, hopefully I'll be able to cobble up an answer for you. So thank you.
Thanks, Paul. Thanks, Paul. I've still got a couple of points that I'd like to take everyone else through. So we've talked about how to do the basics and get the basics right. And now what do you do with all that data that you've just generated for your CMMS system? And again, another diagram from ITIS, which sort of paints it perfectly and sort of echoes what we view within TRIS as well, is that, so you've built your maintenance strategies, your philosophies, and populated your CMMS systems, and you've got all this data sitting in its own silo almost. And some of the work packages you're acting on, others you're less so. And when you've developed all that data, you feed it into an asset performance management solution, or ITIS in this case, where you start deploying these asset strategies and you start monitoring against the potential failures that you've identified. So if you've identified a pump is going to start vibrating stupidly, and that's the measurement that you're taking to sort of identify how the asset is performing, so the condition monitoring there. Or if the temperature gets too hot because the process fluid going through is too hot. And if you're monitoring against these, then you can determine what action is appropriate that should be taken next. And again, you're taking data from your historian or DCS or whatever you've got unplanned, and you're feeding it through again into this asset performance management tool. And again, when you get this multi-level, multi-layered comparative approach, you can action this data. And this is sort of almost how you start to bring in things to life with the data that you've got. Now, the title of this webinar, and it's a point that we need to get across as well, is what is artificial intelligence and machine learning in maintenance and reliability? And I just want to get some definitions down for yourselves. Artificial intelligence is the simulated intelligence of humans by computers or machines. So it is just simulated intelligence. And true artificial intelligence is where the machine is capable of making its own thoughts, whereas machine learning is a type of artificial intelligence. So it's not true AI, it's just an algorithm or a program or an application that's learned a pattern or a boundary of actions that it compares and predicts against. And computers are incredibly great at comparing lines and numbers and bits of data to each other or to other sources of data. But what they're not good at is telling you that something is going wrong if you haven't taught it before or if you haven't showed it before. So if there's a new anomaly that the computer hasn't seen before, it'll be clueless. And that's what I'm saying. So there's a lot of hype around machine learning and artificial intelligence. And it is useful and it's got its place in maintenance and reliability. But without the asset history and the condition monitoring and sort of the consistent rationale behind what this data means and the understanding of what problems you have on site and what are you trying to solve with the data that you've got, machine learning is useless and artificial intelligence becomes useless as well. You need to employ and deploy the proven engineering approaches. Some are listed on the pyramid, others weren't on that pyramid. But there's a number of techniques and you need to adopt the one that's most appropriate to you. And once you've adopted the techniques, you need the people and process. So just because your machine learning algorithm is telling you something, you need someone to act on it and a process to validate or action that data that's being generated. And once you've got all that in place, then you could start to leverage the artificial intelligence or the machine learning algorithms to your benefit. But until then, they can just throw a lot of false warnings that aren't necessarily useful to you. I'm not saying it will solve all your problems or that it won't solve anything, but there's a caveat around it, and it's a big one, that you need the appropriate data and the appropriate rationale and justification behind what the data means and what it's telling you before you can adopt it. So just to summarize everything that we've talked through today is, again, it's a great ITIS slide that I've really thought captures everything really well again, is The first thing you start with, whether through it's an FMEA process, RBI process, or any other process to determine your risk, and you need to start assessing what your risks are on site. You need to know which ones are important, which ones aren't important, which ones you can live with, and which ones you can't live without. Once you've identified the risks, you implement a strategy to protect, whether it's through a CMMS system or any other scheduling routine, or even if it's via sensors or technology to help you mitigate or avoid this risk. If your risk is sensor-based or you're using technology to monitor it, then what is that data telling you? Leverage it, decide what actions you can take, what actions you can leave behind. And the final and most important one is act on what the data is telling you and validate it. Make sure you always validate what the data is telling you. There's no point in just replacing an asset because some data told you to do so. You need to make sure that the data generated the right assumptions that you built in and the right thought process behind it. So going on to the next slide is I want to take you through a couple of case studies just to show you the importance of people process technology and sort of the fundamental understanding of the basics before you move on to technology. So this was quite a great case study for us. So we had a customer called MOL, and they had 4 refineries split across Hungary, Slovakia, and Croatia. And they had issues around how standardized their data was, how different sites operated in conjunction with each other. Some were great, others were far less so. And it was an issue that was causing problems for the senior management within the organization. Again, if you remember the pyramid from earlier, I'm talking about the investment piece. So the top of the pyramid decided we're going to invest in standardizing all the 4 sites. So it wasn't leaving any of them to their own. They just said, let's standardize everything. And they invested a chunk of money into the process. So we were ABB at the time, but we have got the core team within TÜV now, so that's why I've changed it to TÜV. But if you Google the article MOL and ABB, it will come up and you can read into it in a bit more detail. But just giving you a bit more view within TÜV, we broke down the project into 4 phases, although phase 0 is just a prerequisite for us to build the basics. And then you can see how involved we were at the start and sort of towards the end, which we're ongoing right now, we're far less so involved. And phase 0 was just defining what the problem is, what each site needed, and what sort of framework we were going to work towards. And again, once all the 4 sites and the senior management agreed to it, we started phase 1, which is just educating the sites on what is required, what they need to do, and how to do it. Fast forward a few years, we moved on to phase 2, where we were a bit more just teaching and coaching. And this is when we started to implement the digital solutions. So in phase 1, it was just traditional Excel spreadsheets and just educating people on how to do things and what things to look for, what things not to look for. And then by the time we got to this phase, which is phase 3, which is currently ongoing, we're supporting in the asset integrity management delivery. And all we're doing is providing feedback and reviewing the information that they're generating. The site has become almost autonomous and they are doing the integrity management themselves. But you could see the benefit to the customers is there's millions of euros year on year. ABB quoted 9 million. And it's a great figure that a site's getting every year. And they've had systematic improvements and standardization of mechanical integrity, which you can see by the numbers at the bottom, it's introduced a lot of benefits to them. The next case study I'm going to talk about is a chemical site in the States. So this site had a lot of failures with their assets, and they approached us when we were still under ABB. Again, the core team within TÜV is the team that carried out the scope, and it was largely because of Paul Metcalf's team that this work was executed. So at the start of it, we developed a 3-stage process, which is the initial one was to find out what assets are failing and where and how they're failing. And in that way, we could decide we're going to monitor the bits that are going to fail or the bits that are going to go wrong based on the output of the FMEA. We generated the results of the FMEA And through the FMEA process, we realized that the customer and his team didn't understand everything about the process. It was a case of sometimes it worked, sometimes it didn't. Sometimes we had to reprocess, other times they didn't. And we got quite a number of ambiguous answers. And when we asked the customer, so do you know why your assets are failing as much as they do? Is it because you're not carrying out the maintenance when you're supposed to, or and various other factors? We never got a full response. And so when we were doing the technology review of what they needed or what they didn't need, we analyzed the outputs from the FMEA and recommended that they carry out root cause analysis as opposed to deploy sensors or any APM solutions on site. And that was largely because there was a lot of basics that the site wasn't conducting that they should have been conducting. And it just goes to show that APM is not always the answer. You need to get the basics right before you can move into the next stage and the stage after that. Now, the next and last case study for today, I will pass you back to Paul Metcalf because he led this project. So I think it's probably appropriate that he presents it more than I do.
Thank you. I wouldn't guarantee it, Sharif. There's no nothing certain in this life as whether I can even get this right or not. So this project is a relatively recent project for a customer with a steel making plant. In this particular case, iron making, with keeping their assets operational for a defined period of time. This is partly underpinned by the need to move on to green steel making, which is still a relatively new technology, and for an industry which is well rooted in traditionalism and conservatism, nothing moves quickly. So suffice it to say, from the customer's point of view, they want to keep their assets running for a certain period of time in order to assess that transition into green steel making without jumping in too quickly, really. So the challenge for ABB and TÜV as we are now is to work with the customer on keeping their assets operational, pending the introduction of that green steel making. As I'm sure many of you will know from the media, steel making is a volatile market. There is no getting away from that. The demand is up and down depending on the country's financial stance, whether that be for construction or for automotive. It has a significant effect on these systems. So sometimes the demand goes up, sometimes the demand goes down. Because of that, as you can well imagine, I'm sure, there is a need for prioritization of maintenance. There is limited funds available. So you can see now, when we mentioned earlier about RBM, the early sort of seeds forming towards what this client needs in order to spend efficiently. So what we did for them was a project called Forward Cost Assessment, but in reality that is an asset life study, whereby we look at the assets, the information that's available to us in terms of inspection records, maintenance records, interviews with the staff, another potentially important element, because there's an awful lot of corporate knowledge lost in the staff if as they come and go. People build that knowledge and tend to take it with them. So sometimes it's good, well, all times it's good to actually extract that knowledge and get it into documents. And with all this information in mind, we develop a plan, spending profile that helps maintain those assets for the next whatever period they specified, in this case 10 years. We identify compliance gaps. So unlike the issues we mentioned very early on in the RBM discussion, we're looking at making sure our customers are, from a process safety point of view and a legal compliance point of view, that they're 100% compliant. We churn all that together into a recommendation profile, which gives a set amount of spending year on year for the customer, whether that be centered around the RBM methodology or working on their CMS system, or quite simply working on the plant maintenance and breakdown stoppage planning, the intervals when they do major shutdowns for interventions and such like. And from that, they end up with a spend profile which gives them something to work on. We don't tend to provide them with a cost profile that we say, right, we think you can achieve this. It's more along the lines of, we think you should achieve this, that this is what's necessary to keep you going. And then a client has to work around that in order to achieve them goals. So quite a successful project. We have ongoing work with this customer, and that's going to be centered around, on the next stage, probably asset life strategy review. So evolving that strategy based on, as I'm sure a lot of you have seen in the media in recent months, how those timings have changed, or whether that be extended or compressed. Next slide, please, Sharif. So from myself, Alan and Sharif, thank you all very much for your time.